Okay, good evening, ladies and gentlemen. This is Professor David J. Delos I got it there. What I will be discussing tonight is my table, okay? Oh yeah. What I will be discussing tonight is that I cut one cable here into two. The other half is here. Okay. This is a power bank. This was originally connected. So if we charge the power bank, we plug in this what you call this charger here. What did I did? What did I do? I cut this one into two, and I identify the positive and negative terminals, and so with the other one. The significance of this is that if I needed the 5 volt, I'll just plug in this one and I could bring out 5 volts here. Okay? On this portion here, if I need to charge this one, okay, I will just be applying 5 volts here and I could charge the power bank. How come did I do that? I did that one because I just want to prove that the input voltage coming from this what do you call this charger is actually 5 volts. And actually we could verify that one if it's really 5 volts. Okay. Let's try to verify if the voltage coming from the voltage charger is really 5 volts. So what will I do? I will plug in this one. I'll be connecting the negative to the negative terminal of my multitester. And I will be connecting the positive terminal to the red terminal of the multitester. And the multitester is set to measure DC voltage. Let's try to prove if really the voltage output coming from our voltage, what we call this charger, is actually 5 volts. Okay. As we can see it, the voltage coming from the charger is actually, it's not 5 volts, it's 5.3. 5.3. So when the power bank draws current, this will be dropped to 5 volts. So actually we are not overcharging a power bank. Like this one here, the voltage output or voltage requirement for this power bank is actually 5 volts. Okay. So from now on, we could say that the voltage output coming from the charger is 5 volts plus. 5 volts will be pi, 5.3 will be pi, because when the power bank draws current, okay, of course this voltage will be, what you call this, lessen. It will decrease because you're drawing current from it. Okay. So when it draws current, this will go to 5 volts, and this 5 volts is actually the requirement of this power bank here. The significance of this, why I cut it, because if I've got an assembled EMF receiver which needed 5 volts, I will just plug in this one, and I could use this terminal now to power up my AM/FM receiver. Okay, so I will try to remove this one now. Okay, That's why a while ago I made these connections here. Okay, there's a clip here, there's a clip here. The red thing refers to the positive terminal and the black one or the white one refers to the negative terminal. So just in case you are using this one as a power source, just take note that the red one is the positive and the black one is negative. And you could take around 5 volts here to power up any gadget which require 5 volts. That's the significance of this. Okay? What's the other significance of the other one? The significance of the other one, if I would like to charge this one without using the charger, because actually I got a power source over here. I don't know if you can see it, guys. Oh, you can see it. This is the power source. I will try to plug in this power source here. And as you can see, this power source is actually uh, variable. It's variable. Like right now, the voltage is 11.8. I don't have to measure this one because it's indicated already in the LED, 11.8. And I will be using this one to charge this power bank. Okay, so the requirement for the power bank is at least it is 5 volts. So I will set this one to maybe 5 volts. I set it to 5.48. I could set this one to 5.3. Yeah, that's 5.32. So the other way on how I will charge this power bank is that I will be using my variable power supply. I make sure that the voltage output coming from the power supply is around 5 volts or 5 point plus something. Then I will try to remove this one. Okay. I will try to remove that one. And I would like to measure the current uh, for the current consumption of this power bank here. I will be charging this power bank here. So I will be connecting the plus terminal here. I would like to measure the current. Okay. Then I will be connecting this positive terminal. It passes through the ammeter. Okay. It is set to DC amperes. It goes to the plus. Okay. It goes to the plus. And the other one, it goes to the minus. So I'm injecting a 5.3 volts across this power bank here. And at the same time, I would like to measure the current. So I will be connecting this one here. Okay. And as you can see it, guys, the current consumption is around around 0.2. It's going down. Okay. You see the power bank is charging already. Okay. But the voltage is going down, so I'll try to increase this one a little bit. It will go to 5 volts. .6 will be fine. Okay. The current consumption is 0.180 amperes. So meaning to say, I could charge this power bank by using my variable power supply originally it was set to 5.3, but when it draws current of around 0.174 amperes, that's 174 milliamperes, the power bank is now charging. As you can see it, guys, the power bank is now charging. Okay? The power bank is now charging. I will try to do this one so we could see the current consumption. That's the current consumption. I'll try to zoom in. 0.169. The current consumption while we are charging is 0.169 or 168 milliampere. And right now, the power bank is charging by using my regulated variable power supply. Originally, it was set to 5.3, but when it draws current, of course, it will go down. Okay, and right now, the voltage is, the power bank is now being charged. The current consumption is 166 milliamperes. Okay. Okay, you see it, guys? So by using my variable DC power supply, I could charge this power bank, okay, without using the what you call this adapter for cell phones. Okay, I don't want to use this one. I want to use my regulated DC power supply in which the voltage output could be increased or decreased depending on what we need. Like a while ago, I set this one to 5.3. I connected an ammeter in series with the power supply to monitor the current consumption of this power bank. And the current consumption is 163 milliamperes. Okay. That's the significance why I cut this cable here, because for this one here, I could use this one to power up any gadget which I assemble like an AM/FM receiver. If it needs 5 volts, I'll just plug in this one and I could get 5 volts over here. The other thing, the other half, okay, I got my regulated DC power supply. I could adjust the voltage requirement for this power bank that is needed for it to charge. Originally, I set it to 5.3, but when it draws current of around 162 milliamperes, okay, the voltage drops to around 4.60, okay, and as you can see, the power bank is charging. The charge indicator is actually going up and going down. Okay. Okay, that's it, guys. That's how I did my charging of the power bank by using my regulated DC power supply. And the other half, this is very usable, okay? Because if you got a gadget which needed 5 volts, you just plug in this one and you could get around 5 volts over here. Okay. Good evening from Los Angeles. This is Professor David J. DelosReyes. So for those of you who would like to subscribe to my channel is at youtube.com/@ProfDavidJDelosReyes. My channel contains mathematics discussions. It's in long video format and short videos. And the other things are actually topics on electronics. Good evening from Los Angeles.